Hi everyone! In this video, we'll learn how to write empirical formulas. There are two types of chemical formulas. The first is empirical formula, which is the most simplified chemical formula. The second is molecular formula, which is the actual chemical formula. Here's what that looks like. Let's take glucose. Its actual molecular formula, or its actual chemical makeup, is C6H12O6. We can actually simplify this like a fraction. If we divide all the subscripts by 6, we get CH2O, which is the empirical formula. A common skill that you'll learn in general chemistry classes is calculating the empirical formula from the percent composition. There's 4 steps, so I'll write them out here and then we'll look at examples. An easy way to remember these 4 steps is using the mnemonic, grandmother does math. Step 1 is grand, which means change percent to grams. Step 2 is mother, which means convert grams to moles. Step 3 is does, which stands for divide by the smallest number. Step 4 is math, which means multiply to get whole numbers. These whole numbers will then become the subscripts in the chemical formula. Here's an example. A compound consists of 25.94% nitrogen and 74.06% oxygen by mass. What is the empirical formula of this compound? Before we start solving, let's think about what we're looking for. We know that this compound contains nitrogen and oxygen, but we don't know how many nitrogens and how many oxygens. We need to know the mole ratio, which is what the subscripts are. Subscripts tell us how many moles of nitrogen to how many moles of oxygen we need for this compound. All right, let's get into our grandmother does math steps. Step 1 is grand, which means change percent to grams. This is easy, just replace the percent sign with grams. I'll do this for all the elements. Step 2 is mother, which means moles. Convert grams to moles. Here are my moles. At this point, I already have a mole ratio. However, have you ever seen a chemical formula that looks like this, where the subscripts are decimals? No. So I'll have to do more steps to get whole numbers for my ratios. Step 3 is does, which stands for divide by smallest number. I'm going to compare the 1.85 moles and 4.63 moles. 1.85 is smaller, so I divide both numbers by 1.85. The reason I'm dividing them both by the same number is because I have to keep the mole ratio the same. Think about fractions. If you divide both things by the same number, your fraction or ratio stays the same. Here's the result after I divide. See how we've cleaned up the decimals a lot? However, we still can't put 2.5 into the subscript, so we'll keep going. Step 4 is mother, which means multiply to get whole numbers. I need to get rid of this 0.5 and 2.5, so I'm going to multiply both numbers by 2. Again, I'm multiplying them both by the same number to keep my ratio the same. Now I have whole numbers, and these will be my subscripts. The empirical formula of this compound is N2O5. For that last multiplication step, you'll have to know what to multiply by when you see different decimals. If you see 0.5 at the end of your number, multiply everything by 2. If you see 0.3 or 0.6, multiply everything by 3. If you see 0.25, multiply everything by 4. Next, I'm going to show you a problem where you actually don't have to do all 4 grandmother does math steps. A compound consists of 38.67% potassium, 13.85% nitrogen, and 47.48% oxygen by mass. What is its empirical formula? Step 1 is grand. For all of my elements, I'm going to change the percent sign to grams. Step 2 is mother, or moles. I'll convert all of these to moles. Step 3 is does, or divide by the smallest number. The smallest number here is 0.989. Now, do you see how I have 2 whole numbers and the last number is so close to 3 that it might as well be 3? If you see that all of your numbers are really close to whole numbers, you don't have to multiply. Just round and use these as your subscripts. Now, how close is close enough? I would say within 0.1 of a whole number. Thank you for watching. I'll see you next time for molecular formulas.